All right, everybody. I hope you're enjoying doing school from home today. Read the assignment closely. You got a little 15-minute video from me and then a practice worksheet. And I'm going to dive right in because I've got the free software, so I can't go over 15 minutes. So I can promise you it'll be about 14:58. We are going to pick right up where we left off on block day. So the stuff you did Friday while I was out was a little bit of just kind of an enhancement, but I want you to go back to the unit circle where we started making patterns, making connections, and finding patterns all around the unit circle. And now I'm hoping you feel comfortable with 0 degrees, with 30 degrees, with 45 degrees, with 60. I'm hoping you can do degrees all the way around the circle. I'm hoping you can do radians. 0, pi over 6, pi over 4, pi over 3. I'm hoping you can go all the way around the circle, but what I'm going to focus on for this video are these coordinates. And more importantly, where do the coordinates come from? Here's where they come from. The unit circle has a radius of 1. This is a length of 1, this is a length of 1, this is a length of 1, all the way around the circle. So remember, we draw a reference triangle. It's a right triangle. This is a 30-degree angle. This is a 60-degree angle. And this is a radius of 1. And our special right triangle relationships tell us that in a 30, 60, 90 triangle, the smaller leg is half of the hypotenuse. So this has a height of 1/2, which is our y coordinate. Okay? And then the special right triangle relationships tell us that the longer leg right here is the square root of 3 times the shorter leg. And what is the square root of 3 times 1/2? That's where we get our square root of 3 over 2, and that's the horizontal coordinate. So this coordinate right here in lime green, I'm going to make it bold so you can see it, it's the xy coordinate, root 3 over 2, comma 1/2. And it comes from that 30, 60, 90 triangle. Okay? We're just going to focus on quadrant 1 right now, because if you can do quadrant 1, then we will be able to just fold it over the y-axis, then fold it again over the x-axis, and so forth. So this first coordinate is the square root of 3 over 2, comma 1/2. Okay? And I want to make another connection because I'm going to ask you questions like this here in a second. I'm going to say, what is the sine of 30 degrees? Okay? Well, the sine, remember, is opposite over hypotenuse. So the opposite side would be 1/2, and the hypotenuse is 1. So what is 1/2 over 1? Well, that's just equal to 1/2. So the sine of 30 degrees is 1/2. Okay? I'm going to pull up my calculator right here so you can even see when I type that in, sine of 30 degrees, we're going to get 0.5. So it's a relationship that we're going to use around the unit circle. Let's just do it real quick. The sine of, sine of 30 degrees is 0.5. Okay, it's 1/2. So the sine of an angle is always the y coordinate. Let me highlight that. Okay. The sine has to do with the opposite side, and the opposite side is the one that's going vertical. So the sine is the y. Okay, the sine is the y. The cosine is going to be the horizontal side, because that's the adjacent. And cosine has to do with adjacent. So the cosine of 30 degrees is the adjacent, square root of 3 over 2, over the hypotenuse of 1. The hypotenuse is always 1. So the cosine is just square root of 3 over 2, the cosine of 30. It's this coordinate right here that I'm highlighting right now. Okay? So the cosine is always the x coordinate, and the sine is always the y coordinate as we move ourselves around the circle. Okay? Go to your notes where we left off. It's right here. We just did the big chart, and then right below it. Okay, I want to give you some reminders here. The sine is the opposite over the hypotenuse. But when we're talking about the unit circle, another thing that you can say is that it is the y coordinate over the radius. And when the radius is always 1, let's just put out front that the sine is the y. Okay? The cosine is the adjacent over the hypotenuse, which is the x over the radius, which, since the radius is always 1, it's just the x coordinate. Okay? And then the tangent, which we don't use as much, that's opposite over adjacent, which is the y over the x, which is just the y. It's the y over the x. You actually have to do a little division for that. Okay? So those are the trig functions. So you know how we got the big chart? This is the mini chart. And I told you I'm not a fan of memorization. This is the one chart that you need to memorize. Because if you notice, 0, 30, 45, 60, 90, this is basically just quadrant 1. And we are going to memorize the sine of 0, the sine of 30, the sine of 45, the sine of 60, and the sine of 90. What we're memorizing there are these coordinates. The sine of 0 is that coordinate, the sine of 30, sine of 45, sine of 60, sine of 90. It's all those red circles. And then the cosine of 0, the cosine of 30, the cosine of 60, the cosine of 90, or 45, 60, 90 in the green circles. Okay? And I think this chart is the best way to memorize it, because the sine of 0 degrees, the y value, remember this is the y, this is the x. The sine of 0 is 0. Okay, the sine of 30, we just did that in the notes, rewind it, was 1/2. Remember? The sine of 45, let's go back to our unit circle. Okay, I'm going to clean this up a little bit. I was using that to teach, but let's go back to just a blank unit circle. The sine of 45 degrees would be this 45-degree triangle. Do you remember what this leg was and what this leg was for the 45, where they're both the same? It's not 1/2 and square root of 3 over 2. What was it that was in the middle? Y'all were great at finding that pattern. It was actually the square root of 2 over 2 for both. So that's our x coordinate and our y coordinate. Square root of 2 over 2. So the sine of 45 is the square root of 2 over 2, and the cosine of 45 is the square root of 2 over 2. Both the x and the y are the same on that one. Okay? Sine of 60. Well, sine of 60 would be this. Here's a 60-degree triangle. And what is the y coordinate right there? What's the longer one? It's the taller one this time. So this time the taller one is root 3 over 2. And the shorter one is 1/2. So the sine is a sine of 60, opposite over hypotenuse, is root 3 over 2. So the sine of 60 is root 3 over 2. And the sine of 90, this coordinate right here, what's the y value of that dot right there? Remember, if this is the origin 0, 0, and this is a length of 1, this must just be up one coordinate, 0, 1. So the sine is always the y. The cosine is always the x. So sine of 90 is 1. Okay, so when you're looking at this little chart, it's always, this is the first row. Counts up, 0, 1, 2, 3. It's kind of a way that you can memorize it. And then it goes in reverse. 0, 1, 2, 3. Notice the sine and the cosines, they're switched. Okay. Tangent, remember, is y over x. So what is 0 divided by 1? That's 0. Let's jump to the far right side. What's 1 divided by 0? Well, that's undefined, anything divided by 0. Let's go to the middle one now. Root 2 over 2 divided by root 2 over 2. Well, that's just 1. And then these, I could show you the math. 1/2 divided by square root of 3 over 2. But I'll just tell you it turns out to be root 3 over 3 when you rationalize it. Okay? And then root 3 over 2 divided by 1/2 the other way turns out to be root 3. So take a look at this chart. Pause the video and memorize this bad boy. Okay? The more you can memorize it, this is quadrant 1. Everything is based off of this. Okay? For these last 5 minutes of the video, I want to show you how you're going to use this chart combined with this down here. You all were great at this, but just a refresher. If the cosine is the x and the sine is the y, then in quadrant 1, both the x and the y are positive, which means the tangent is positive because you just divide those two. In quadrant 2, the y is still positive, but the cosine is negative because the x-axis is negative over here, which means the tangent will be negative. Down in the bottom, remember quadrant 3, they're both negative down here. Negative x and negative y, which means the tangent will be positive because a negative divided by a negative is a positive. And then in quadrant 4, the sine is negative because we're down here, but the cosine is positive. Okay? Using this chart and these, just thinking about the coordinate plane, I want to show you what your homework is going to be. Okay? It's going to be just like this. I'm going to ask you a question like, what is the cosine of 30 degrees? Okay? And here's the key. Knowing the reference angle, which we did on block day. What's the reference angle of a 30-degree angle? You can imagine what a 30-degree angle looks like. It looks like this. Okay? The reference angle is 30 degrees. What quadrant is a 30-degree angle in? Well, it's in quadrant 1. So then we go to our chart. What is the cosine of 30 degrees on our chart? We look back at this. Okay, I'm switching to green. What is the cosine of 30 degrees? Cosine of 30 degrees, that is right there. The square root of 3 over 2. So the cosine of 30 degrees is the square root of 3 over 2. Okay, so when it's quadrant 1, it's going to be just straight off the chart. So you'll get comfortable with that. But what if it's not quadrant 1? What if it's like number 3, 225? Well, the key is knowing the reference angle. Because as long as you know this chart, you know all the reference angles. You're always going to get either 0, 30, 45, 60, or 90. And the radian version of that is 0, pi over 6, pi over 4, pi over 3, and pi over 2. So we're always going to be living right here as far as reference angles go. So what is the reference angle of 225? How close is that to the x-axis? Well, that's 45 degrees away from 180. So it's a reference angle of 45. What quadrant is that in? 225. That's in quadrant 3. So what is the tangent of 45? Well, go to our chart until you're ready to not use this. What is the tangent of 45? Here's tangent. Here's 45. We go to that square, and the tangent of 45 degrees is 1. So we put a 1 there, but we got to be careful. The quadrant determines if it's positive or negative. So let's go back. In quadrant 3, which is down here, well, let's use Roman numerals. Quadrant 3, is my tangent positive or negative? It's positive. Okay, so we're good. Positive 1. Bingo. Let's do a couple more. Let's do the cosine of 300. What is the reference angle? I put this here for a reason. You've got to follow this way. Cosine of 300. How far away from the x-axis is 300? Well, that's 60 away. So we got the reference angle. What quadrant is 300 in? It's in quadrant 4. So instead of finding the cosine of 300, I'm actually finding the cosine of 60, which is on our chart. Okay, once again, I'm using green here. Cosine of 60 is right there. You see how if you identify the reference angle, you will always be pulling from this chart. Cosine of 60 is 1/2. But then final question is it positive or negative? That's what we got to figure out. This is quadrant 4. Is cosine positive or negative in quadrant 4? It's down here. Quadrant 4, the cosine, the x is positive. So this is positive 1/2. Last one, let's finish one that's a negative right here. Okay, let's go sine of, let's go cosine, no, let's go sine 7 pi over 6 right here. How do I do the radians, Smith? Well, the radians are actually easier because if you see a 6 on the bottom, you automatically know what's 180 divided by 6. That's a 30-degree reference angle. Okay, sine of 7 pi over 6. That's quadrant 3. And my video is about to end, so I'll tell you this. Sine of 30 is 1/2, and it's negative. Good luck.